Hello students, welcome to the e-learning. In today's session, students, let's learn about Combustion and Flame Part 2 of Class 8 NCERT. So students, let's start with the session. In this session, students, the contents which we will be considering are flame, what is flame, then we'll do about structure of flame, different zones of a candle flame. Then we'll learn about fuel and its type, a fuel efficiency in form of the calorific value of a fuel, and then the characteristics of an ideal fuel. And lastly, we will discuss about the harmful effects of burning of fuel. So students, let's start with the flame. We all see that when we are burning a candle, it gives out a colored part, which we commonly call as flame. So, what is a flame? By definition, a flame is a region where a combustion of a substance takes place. So, whenever we are burning a wax candle, it gives a flame. Now, what condition should be there to have a flame to occur? So, a flame is produced only when there is a combustible substance, and when it burns, it vaporizes on heating. Whereas if a combustible substance which does not convert into the gaseous form or it does not vaporize, it is it is unable to release a flame. For example, when the coal is burnt, it does not produce any flame. The reason is that when coal is burning, it does not converts into vapors. Rather, it gives out more solid carbon particles. Hence, it does not show any flame. So, for the flame to occur, the combustible substance should vaporize on heating. That is why it is imparting a color. It means the vapors approach to such a high temperature that they start giving the color. Now students, let's see the structure of the flame. What parts it has and what characteristic each part has. So if we take a wax candle and burning, we see that the candle shows the flame shows the different zones. The very first is the non-luminous zone, and this zone is the outermost zone, which is of high heat content. It means here the temperature is very high and almost the whole combustible substance is converted into the vapor form. The second zone is the luminous zone, which is basically responsible to give out the light. And if we see this zone, in this zone, the temperature or the heat content is moderate and it has a good number of unburnt carbon particles. This can be examined if you insert a glass plate and into it we find that on a glass plate a circular carbon ring is formed, showing that in this zone a large number of carbon particles are present. Then the third zone is the dark zone or the zone which is said to be the least heat content or the cold zone, which appears to be dark in color. More broadly, we can just see the different zones of a candle flame as the outer zone, which is said to be the oxidative zone because of the presence of oxygen, and hence there is a complete combustion of the uh, combustible substance, and this zone appears to be blue in color. Then comes the middle zone, which is a non-oxidative one, where there is not a sufficient supply of oxygen. There occurs a partial combustion and this imparts a yellow color. It is moderately hot temperature is not very high. Then comes the innermost zone, which is also a non-oxidative because of the insufficient supply of oxygen, and it appears to be black in color. Here most of the wax, if we are talking about the wax candle, unburnt wax vapors are found which are black, and it is the least hot zone of the flame. Now students, let's see about the fuel. The very first question is, what is fuel? Fuel is any combustible substance which is capable of giving the heat on burning. It produces heat and light and can be used for some good purpose. So there are variety of fuels. Now how these variety of fuels are obtained? They can be obtained on various bases. The very first basis is the source from which they are obtained. Most of the fuel are obtained naturally. So on the basis, they are categorized as primary fuel and secondary fuel. Primary fuel are all those natural fuels that are obtained, and they can be used in that original form to produce heat, such as wood and coal. They are primary fuel. The way they are obtained, in the same form they are being used for the combustion process to give out the heat. The secondary fuel are also obtained from the natural source, but they are being processed for burning. For example, petrol. Petrol is obtained from petroleum, and it is obtained by the refining of the petroleum. So it is a secondary fuel. Likewise, biogas, which is obtained by the decomposition of the agricultural waste and the bioproducts. The gas is being which is released is the secondary fuel. Water gas is also one such secondary fuel. Then on the basis of the physical state of a fuel, there are three different type of fuel: the solid fuel, the liquid fuel, and the gaseous fuel. The solid fuel appears in the solid form at room temperature. Examples are wood and coal. The liquid fuel appears to be in the liquid state at room temperature. The example of liquid fuel are petrol and kerosene. And the gaseous fuel appears to be gaseous in the state at room temperature. The example of the gaseous fuel are CNG, or compressed natural gas, and hydrogen gas. Now, the third way of classification is on the basis of their use. They are classified as renewable fuels and non-renewable fuel. Renewable fuel means all those fuel which can be obtained in a short interval of time, and um, they will not finish very fast. The example is biogas, which is obtained from the agricultural waste, and wood. Whereas non-renewable kind of fuel are the one which one finished will not be obtained in a short interval of time. We cannot get them back easily. Examples are fossil fuels such as coal and petroleum. Students, now let's see the fuel efficiency. Means what is the capacity of a fuel to give the heat content. How much heat content a fuel is releasing so that it can be used efficiently. And for that, to find the efficiency of fuel, we measure the fuel efficiency in terms of calorific value. Now, what is calorific value? By definition, calorific value is the amount of heat which is being given by a unit mass of a fuel, such as 1 kg of fuel, on burning completely in presence of sufficient amount of oxygen. Means when there is a complete combustion of the fuel in sufficient oxygen, whatever amount of heat energy is released, that is termed as the calorific value of a fuel. It is a measurable quantity, and the SI unit to measure calorific value is kilojoules per kg. Kilojoule is the unit to measure the heat energy, and kg is the unit to measure the mass of the fuel. Let's see some examples of certain fuel which on burning, how much heat they give out, which can be measured in terms of calorific value. So the calorific value of the certain fuel are for LPG, it is 55,000 kilojoules per kg, which means on burning 55,000 kilojoules energy is released when 1 kg of the LPG is burned. Likewise, 1 kg of petrol on burning produces 45,000 kilojoules of the heat energy. And when 1 kg of coal burns, it gives the heat energy which ranges between 25,000 to 33,000 kilojoules of heat energy. Now, in case of coal, as we know that coal occurs in variety such as peat, lignite, bituminous anthracite. So, the range is between 25,000 to 33,000 kilojoules. Now, here we observe that the gaseous fuel have got more calorific value as compared to the solid. It is just because when the gaseous fuel are burning completely, the reaction is directly with the gaseous oxygen. Hence, they are releasing out more heat energy as compared to the solid one, because solids, when they are burning, some amount of energy is being utilized by the solid components to convert into the gaseous form to combine with the oxygen. So some amount of the energy is being utilized in the conversion of the gaseous form. Hence, their calorific value is comparatively lower than the gaseous fuel. Now, calorific value is a measurable quantity and it can be measured. It is measured by an instrument called calorimeter, and there is a mathematical formula to find the calorific value, and it is given by the calorific value is equal to the amount of heat released by complete combustion of a fuel to the mass of the fuel used, and this will give you the value of the calorific value. Now students, let's learn something about the characteristics of an ideal fuel. That how can a fuel becomes an ideal fuel? The very first is that it should have a high calorific value. It means on burning it should produce a large amount of heat energy, and it should have a moderate rate of combustion. It means it should not burn immediately. Rather, it should be burning moderately to release out the heat energy. Then it should have a moderate ignition temperature. It means some amount of heat should be supplied to start with the combustion process. It should not be at a very low temperature or at a very high temperature. And it should be easily available and should be economical. Means it should not be very costly to purchase. Then it should be easy to transport and store, and lastly it should not release the harmful gases on burning, because if they release harmful gases on burning, it may harm to our environment. So that cannot become a ideal fuel. Now students, let's see the harmful effects of burning of fuel. Whenever the fuel is burning, they are releasing out some gases and some other components. They may be harmful. Let's see what are the harmful effects of burning of the fuel. The very first harmful effect is the release of the particulate matter such as the unburned carbon particles. There are various sources which are using the fuel, and on burning they release the particulate matter, such as the cars and trucks. They are using the liquid fuel, and when there is the burning of this fuel, they release out a large amount of smoke. The smoke is nothing but the unburned carbon particles which are released along with the exhaust gases. Mm. Even the factories which are using the coal for their processing and all that, they release out a large amount of smoke through the chimneys, which contains a large amount of unburned carbon particles. Now, how these unburned carbon particles are harmful? As these carbon particles are very light in weight, they remain suspended in the air. So they are also termed as the particulate matter or the suspended particulate matter. They remain suspended in the atmosphere, so they are giving various effects. The very first effect is the low visibility. As they are light in weight, they are not settling down, so they remain suspended, decreasing the visibility. They do not allow the sunlight to enter completely, which can affect the plants and the growth of the plants. As well as they remain suspended in the air is being inhaled by the living beings. It enters into their body and cause a large number of respiratory disorders and diseases such as asthma, bronchitis, and many times it can cause lung cancer also. The another harmful effect of burning of fuel is the release of carbon dioxide. As we know that most of the fuel when burned, they release carbon dioxide as the byproduct. And this release of carbon dioxide is very frequent in case of the petroleum product as well as the coal. Now, if this carbon dioxide is released, the sources from which they are being released, the major sources are the electric and heat production units, where the energy is generated by burning the coal or the petroleum. As well as the major sources are the transport sources like the cars and the buses and the trucks, which use the petroleum products for as a fuel in it. So they are emitting a large amount of carbon dioxide into the atmosphere. The effect of releasing of the carbon dioxide into the atmosphere becomes harmful. Though the presence of carbon dioxide is important, because the presence of carbon dioxide in the atmosphere is actually showing an effect which is called as a greenhouse effect, which is actually maintaining the life and sustaining the life on the earth. But if the concentration of this carbon dioxide increases, it has a harmful effect, and the effect is the global warming. The global warming is actually a increase in the average temperature of the globe, which will result in the melting of the ice cap. It means even by 0.1 degrees increase in the average temperature occurs, it may have an adverse effect. It will make the ice caps to melt very fast, which will increase the sea level, and that will make all the coastal areas to get submerged in water. So this is a very dangerous effect, and we should be conscious about, using the various fuels, how we can use it efficiently to decrease the emission of carbon dioxide in the atmosphere. The third harmful effect of burning of fuel is the release of carbon monoxide. Carbon monoxide is released when there is an insufficient supply of the oxygen during the combustion process. Complete combustion does not take place, hence carbon monoxide is released. Carbon monoxide is a colorless, odorless, tasteless gas, but it is very harmful because it combines with the hemoglobin when it is being inhaled by the human beings, and it combines with the hemoglobin. It forms a compound called carbon monoxyhemoglobin. Now, this carbon monoxyhemoglobin, which is formed, is having a capacity to solidify itself, which can cause a blood hemorrhage. The carbon monoxide has got a greater tendency to combine with the hemoglobin as compared to oxygen. So, if it is being inhaled, it can cause an adverse effect on the human life and can cause a sudden death due to the blood hemorrhage. Now coming to the fourth harmful effect of burning of fossil fuel is the release of oxides of sulfur and nitrogen. As we know that the petroleum has some compounds of sulfur and nitrogen in it. So when they are being burned, some amount of sulfur and nitrogen combines with the oxygen to form the oxides of sulfur and nitrogen. This when goes into the atmosphere, it combines with the water vapor to form the acid, and it drips down in the form of acid rain. So it is forming an acid rain which can be very dangerous and harmful. When it is dripping on the crops, it harms the crops. On building, it harms the building by corroding the rocks and the bricks. And when it is falling in the soil, it increases the acidity of the soil, which can have an adverse effect on the growing of the crops. So that way, the release of oxide and sulfur, oxides of sulfur and nitrogen are harmful. So in this session, we have learned about the flame, the zones of flame. We have learned about the fuel, the calorific value of the fuel, and the harmful effect of the burning of fuel. That's all in this session, students. Thank you.